Here we go. This is, I think, the last video that I'm doing for this assignment. It's for number 77. It's a find a min max, or min or a max on this function. So I believe you have to do 79 and 81 as well. You may not I'm going to use, you'll see why, I'm going to use second derivative test because I think it's easier here. You don't necessarily have to do that. You could do it for 79. You could also do first derivative test. Anyway, so I want to find mins and maxes on this thing. So the first step I do is I derive it. So y prime is, my power rule just gives me an x because the squared and the 2 in the bottom cancel, and then I get minus the derivative of ln of x is 1 over x, like this, right? Let me check something real quick. Alrighty, so this guy may look a little bit funky, but I want to set it equal to 0. 0 equals x minus 1 over x. Now, this is kind of subtle. We haven't done one like this in a while, but I actually have two critical values for this function. The first one is when it's undefined. If you remember, I get critical values when it's undefined or when a function is 0. So with this guy, you can see that if I have a 0 in the bottom there, it's undefined. So I actually have critical values. I get 1 at x equal to 0, and 1, the other one I'm going to solve for here. So, and that's from it being undefined. The other one is from solving this equation right here. I'm going to take the negative piece and move it over, so I get 1 over x equals x, like that. And now I can, if I look at this, well, 1 over something is equal to something. I could think in my head, oh well, the number 1 works there. Or if you were to multiply by x, you would get x squared equals 1, which I can see that it's 1. So I also get it at x equal to 1. I guess, if I'm really careful here, I also have one at x equal to negative 1. But, here's the problem with those three, and you may be like, well, I didn't get them anyway. But I've got ln of x, and you should know that ln of x looks like that. It's got a vertical asymptote there. It isn't defined for any negative values, and it also isn't defined. It never hits the x-axis. So this guy is out, and this guy is out because they're not part of the domain. They're not part of the domain of this guy, which means they're not part of the domain of y, which means that we don't care about them in terms of the derivative. So there's only one value that I have to worry about. So let's keep going. I know I'm going to rewrite. Hold on. So I reorganized some of my information here. I know that y prime is equal to x minus 1 over x. That was from above. And I know I get a critical value at x equal to 1. So I could try to plug in different numbers and stuff like that, but I think the second derivative test is much easier to work with here. Well, I see that this is x times, or sorry, minus, this thing is really x to the negative 1. When I derive this, y double prime, I get 1, and then I get a double negative for my power rule, so I get plus x to the negative 2. Now, if you think about this, I can even rewrite it if I really want to, but I don't have to. 1 over 1 plus x squared. It doesn't matter what numbers I plug in at all. It's always going to be positive, right? So the second derivative is always positive, which means it's concave up, which means that at my critical value, I get a, well, if it's concave up and I have a critical value, then I have to have a minimum. So I get a min at x equal to 1. Now, I want to look at the book real quick and check. Locate any relative extrema and inflection points. Well, I could say they're at the x equal to 1. Do I want to plug it in? It's really not that bad to plug in, is it? X squared over 2. So it was x squared over 2 minus ln x. So, with this one, it doesn't specify really. It's unclear whether it wants x coordinate or y coordinate both, so I'm going to give it both. So when I plug in 1, I get 1/2 minus 0. So my min is at 1, comma 1/2. Right? Did you do that right? I think you did. Talk to myself.